right, let's start this first practice session that we're going to do with CSEC Math, and this topic we're going to review is number theory and computation. So the exercise that I'm going to do is related to that topic, and everything in this multiple choice paper should be completed by you by now. If it is that you can't complete it by now, then go along with me and try and understand how to solve the problems that are listed here. So these are typical examples of what you would find in your CSEC math examinations. So we have 20 multiple choice questions that we're going to work through, and then we have 5 structured type questions that we're going to answer. Well, 6 actually. All right, so it's not going to take long, and I'm going to also show you a few calculator tricks that you can do as well. All right, now first off, multiple choice, you can't really use a calculator, so we'll try to stick with that and do most of our calculations by hand. And I will show you how to do some quick mental maths as well to do the calculations faster. So with that, let's try and get started. So 3 squared, negative 3 squared is equivalent to saying negative 3 times negative 3, and we all know that. So I'm just going to work out the values now. So this here would be 9, and this here would be 4, and I'm adding the two of them to get 13. So this is our answer here. Next, what number when added to 1/3 gives 2? So a number, when I add it to 1/3, is going to give me 2. Well, I don't know what this number is. So what I can do is I can just simply try and figure it out. I am going to first write 2 as something over 3. So let me write that as something over 3. So if I say 2 as something over 3, it's 2 over 1. And if I times it by 3, I'm going to times this by 3 as well. And I'm going to see I'm going to get something like 6 over 3. So something plus 1 over 3 is going to be 6 over 3. I know that if I'm adding fractions, the denominators have to be the same. So that means both of them need to be over 3. Plus 1 is going to be equal to 6 over 3. So something plus 1 is equal to 6 because the top matches with the top and the bottom matches with the bottom. I know that this here should be 5, so that means 5 over 3 is what I should have in this empty box up here. So that means the answer is B. The next one, Anne and Betty share sum of money in a ratio of 2 to 3. Anne received $60 less than Betty. What was the total amount of money shared? So the total shares is equal to 2 plus 3, which is 5 shares. Now, if we look at the shares, this here is Anne's share, and this here is Betty. Now, Anne received $60 less. The difference in shares is 3 minus 2, which is 1. So that means one share is worth $60. Okay, if one share is worth $60 and we have a total of 5 shares, then 60 times 5 would be equivalent to what? 6 by 5 is 30, with a 0 here, that's 300. So the answer is D. Next one, if 235 times 48.7 is equal to 11444.5, then 23.5 times 0.487 is equal to what? In this question, all we have to do is just look and see how many times we shift the decimal places. So if we look at 235 first, and then we look at 23.5, to get these as equal to each other, we simply have to shift the decimal point one place to the left. Then we look at the next number, 48.7, and we're looking at 0.487. To get those to match, we have to move the decimal point 2 places to the left as well. Now, that means a total of 3 places need to be moved in the answer, and the 3 places is to the left. So 11444.5, moving 3 places to the left, 1, 2, 3, and we're looking for any answer that's equivalent to 11.4445, and that answer is A. Next, what is the square of 15? Now I'm going to show you a quick method I would use to calculate squares. So 15 squared, and what I'm going to do is I'm going to break this up into 2 numbers. I'm going to break it up into numbers that are something multiplied by 10. So if I want to multiply by 10, then I can see that 15 needs to minus 5. So I minus 5 here to reach 10. And since I'm doing that subtraction of 5, I'm going to need to add 5 to the upper limit, which is going to reach me to 20. All right. So I'm going to add and subtract 5 in this case so I can have something in terms of 10. I do that multiplication and I get 200. The next thing I have to do is take this number here, which is the 5, and square it. 5 squared is 25. The answer is 225. And it goes very fast once you get a hang of this process. So the answer here is B. 540 beads are shared in a ratio of 4 to 5. The larger share of the bead is what? So we know that total shares is equal to 4 plus 5, which is 9. We're looking for the larger share. We know that each share inside of this will be worth 540 divided by 9, which is 60. So each share is worth 60. If I'm looking for how much 5 shares is worth, which is the larger share, then I simply multiply it by 60, and 5 6 are 30, with a 0, 300. Now I'm going to take these and correct to two significant figures. Okay, now doing this kind of calculation can be very tedious, but we can do it quickly if we use the distributive law. Let's look at this. If I take 19.00 and I minus 0.04, this is the same as this value over here. Also, if I decide to take this number and write it as 2.00 plus 0.03, I can get that equivalent over here. Now, I just apply the distributive law and it will be faster for me to calculate this rather than calculating this. So let me calculate this with distributive law. 19 by 2 is the first thing. So 19 by 2 would be 20 plus 18, 38. So, okay, 38. Then we go this by this, which is 19 times 3. 19 times 3, 30, 27, 57. And I need to shift 2 decimal places, 1, 2 here. So 1, 2 here, 0 plus 0.57. Then I take this and multiply by this, which is 4 times 2, which is 8. And I count 1 2 decimal place on this factor. So 1 2 decimal places, 0.08, like that. Add that. And then finally, this one over here, which is 4 times 3 to give me 12. And that is 1 2 3 4 decimal places. So 1 2 3 4 decimal places, 0.0012, so plus 0.0012. I just simply need to add these together, so I'm just going to write it out here, 38.0000, and then I would put 0.57, 0.08, and then 0.0012. So I have 2 over here, 1 over here. 8 and 7 would give me 15, so put a 5, carry 1, which is 6, and then have 8 here, and then 3 here. And that is my answer. Rounding off to 2 significant figures. So I count 1, 2 significant figures. This is my cutoff point here. This number here is greater than 5, it fits the condition, greater than equal to 5. So I add 1 to this, and I will get 39. So my answer is B. 0.45 written as a common fraction in its simplest form. Okay, so what we do is we take 0.45 and underneath it we replace this decimal point with a 1. Well, we're not replacing it, we match that decimal point with a 1 and every digit after with a 0. So we have 45 over 100 and we just simply work that out. So 5 into this is 9, 5 into this is 20, and we get 9 over 20, which is A. The exact value of this is equal to what? Okay, so we are taking 37.26 and we're adding 1.8 to it. So I'm just going to show you how I add. So I take 6 and I put it here. 8 and 2 will be 10. So I put 1 here with a 0 here. 7 and 1 is 8. So I put that 8 here, and then 3 is that. So I just put that down and I just put them together. So 39.06. And then I divide by 1,000. 1, 2, 3, which is 0.039, 0.039, and 1. So that answer is B. Right? So it rounded off. Right? So it rounded off here. Right? It rounded off. So this here was following the condition greater than or equal to 5. So we add 1 to here. So that's how you get your 0.0391. All right, let's go for this one. So to solve this problem, it looks complicated, but it's not. We simply use distributive law. All right, we use distributive law, we reverse it, and you'd see that you'd be getting something in common here and here. So it's 2.5 into 3.3 plus 5.7, which is the same as saying 3.3, 5.7. That is 3 and 7 is 10, so I put 10 here, and then 5 and 3 is 8, so I put an 8 over here, and then I would be able to get 9.0. So I take the 25 and I multiply it by 9, and I'm going to get 9 by 2 is 18, and I have a 2 in the I have a 2 in the tens position, so I need to add a 0 to that 18. And then 9 by 5 is 45, so I put 45 here. And then I add them together, so I have 5 here, 8 and 4 is 12, so I put the 12 over here. And then 1 brings that down over here, and I'll be able to get 5, 2, 2. And I have one decimal place to move it, 22.5. So the answer is D. All right, let's go to the next one. So the highest common factor of 12, 15, and 60. Okay, so this one is easy. We're going to use prime factorization. I don't like to use anything else other than prime factorization. So 12, 15, and 60. And I'm going to write the products as prime numbers, the product of 12 as prime numbers, 12 as a product of prime numbers, sorry. So I will say 2 times 2 times 3, and then for that would mean 2 to the second power times 3. Similarly, I'm going to do the same thing for 15, so I'm saying 3 times 5, and then I'm going to do the same thing for 60, which is 2 times 2 times 3 times 5, which works out to be 2 to the second times 3 to the first power times 5 to the first power. Now, if I watch, I can see that the only thing that is in common to all of them is this 3 to the first power here. I don't have anything else in common. 3 to the first power is 3, so the answer is B. All right, next. The next term in the sequence is this. Now, we can do a common difference between the two of them. So, difference between 6 and 1 is 5. Between 6 and 13 is 7. Between 13 and 22 is 9. And between 9 and 33, it's 11. We can see that difference between 5 and 7 is 2. Difference between this is 2. Difference between this is 2. So we notice that this sequence is following some kind of quadratic equation. All right. Now, since it is that it's following some kind of quadratic equation, what we can do is we can try and work backwards with this last digit and figure out something. So we can take 11, add 2 to 11, and we get 13. And then we can take the 33 and add 13 to it. 13 plus 33, and that will be 46. And our answer is C. Next, we can see by using the distributive law, what is the equivalent? So we can see that this here is a common factor to both of these numbers, I should say here, right? Both of these numbers, this factor here and this factor here is the same. So I factorize 49 and I put it as 17 plus 3, since plus is the operator in between it. Next, I add them and I see I will get 49 times 20. Which is the answer D. Next, I'm supposed to write this in standard form. So I have 0.0325, and I'm going to write this in by some power multiplied by 10. So I can see here 1, 2 places so that I can get 3.25, and that would mean I need to put 10 to the power of minus 2 since I moved to the right, and that answer is B. The largest prime number that is less than 100. Okay, so as long as none of these numbers have another value that divides them, then that is the largest prime number. We can see right away that 99 is divisible by 3. So 3 into this, 3 and 3 into this, 33. So the next thing that we have to check is 97. 97. I can't think of anything that can divide 97. So I would say that this here is the first prime number that is largest. Similarly, let's look at 93 just to confirm. I can divide this by 3. 3 into this 1, 3 into this is going to be equal to 3, and then we have a 1 over here. When we look at 91, I can't think of anything, so it's also prime, but it's not the largest prime, right? And usually what I do is I just go straight up until about 10. So divide by 2, 3, 4, 5, 6. 6, I'm not seeing a divisibility by 6 here. 7, 8, no 9, no 10. Let's see 7. 7 into this would be 1, and then carry the 2 over here, and then that's 13, 7, right? So it's not prime, okay? So definitely this is not prime, this is not prime, and this is not prime. This is the only prime number that we have, and the answer is C. All right, let's go to the next one. Okay, 16. So if 3n is an odd number, which of the following is an even number? Okay, let's say we have the numbers 1, 2, 3, 4, 5, 6. And let's say we're looking at the number 5, right? Let's say 3n is looking at the number 5. If 3n minus is 1, then we can end up here, which is 4. If 3n was representing 3, if 3n was representing 3, subtracting 1 will end up at 2. So we can see that for every odd number that is represented by 3n, we will be able to go back to an even number if we minus 1. So this is our answer here, right? And you can check the other one if we add 2, where we will end up. So if we add 1, 2, we end up at another odd number, all right? Even if we subtract 1, 2, we end up at another odd number. So it can't be the others. Anyway, express this as a fraction in its lowest term. Okay, so again, we follow the same format as we did previously. We take 0.12, and for the decimal point, we put a 1 for each digit after we put a 0. So we have 12 over 100. Next, what we're required to do is divide this and put it in its simplest form. So 2 into this is 6, 2 into this is 50, then 2 into this will be 3, and 2 into this will be 25. So 3 over 25D. The product of two consecutive odd numbers is 143. What are the numbers? Okay, well, I would just usually multiply these out. It will take too long if I were to go about another method and simply solve and determine these values. It will take long, and it will be a little bit tedious, right? So you can solve this using algebra, or you can just use trial and error. What I would do is I would count out what I already know. So this here is 99 and this here is 63. So I definitely know it's not these two. It's probably one of these two. Let's do a quick product of each of them and see which one it is. So 13 by 11. Now anything multiplied by 11 follows a nice little format. All you have to do is put the initial number here, put the final number here, so the 1 and the 3, and then add them up and put it in the center, 143. And that's it. That's your answer. And this works out very nicely for any number that is by multiplying by 11. So like 23 multiplied by 11, you just simply say, oh, okay, well then split the numbers and then add the digits and put it in inside of here, so which is 5. And you can check that if you wish. All right, so 23 times 11, 2 by 1 is going to give me 2 with 2 zeros, since I am multiplying two numbers that are in the tens position. So 0, 0. And then I have 1 by 3, which is 3. I have one number in the tens position multiplying, so I put a 0. 2 by 1 is 2, and I have one number in the tens position, and then 3 by 1 is 4, so I put that down here, and I get 2, 5, 4. All right? Oopsie, 2, 5, 3. Why did I get this 4 in here? 3, 3. 1 by 3 is 4. Oh my god, I add the two of them together. Anyway, so 253. So notice you get the exact same answer here. If it is that you add the digits and it's greater than 9, then what you have to do is you just have to put that extra digit over here when you're adding it. So let's say you're taking about 16, no, let's say 56. Let's say 56 by 11, right? 56 by 11, you take the 5, you take the 6, and then you add them, you get 11, so you put 1 here and 1 here, and you get 616. And you can check that out. 56 by 11. So 5 by 1 is 50 with 2 zeros. Then 6 by 1 is 60 with 1 0. 6 with 1 0. 5 by 1 is 5 with 1 0. And then 6 by 1 is 6. And notice that we have 500. 6 and 5 is 11. And then 6. So this here is 616. All right. So answer is B. All right, let's go on to the next one. The square root of 181 lies between what numbers? Okay, so for this one, all I have to do is figure out where it's going to be. So I will think to myself, okay, let's find the squares of each of these numbers. All right, let's find the squares of each of these numbers. So let's find the square of, okay, so I can tell right away it's not going to be this. All right, I can tell right away it's not going to be this. And then it can possibly be this, but I know that 13 squared is 169. Let me check 13 squared. All right, let me check 13 squared. Let me just make some space here. All right, so let's check 13 squared. So see, 13 squared is the same as saying if I plus 3, I will get 16, and if I minus 3, I'll get 10. So 16 by 10 is 160, and then 3 squared is 9, so that's 169. That is still too low. So it has to be greater than 13. That gets rid of this answer and this answer. This answer is the only answer that remains because this one here is too large, right? 45 squared is going to be really large. It's going to be 50 by 40. So 50 by 45, 4 is at 20 with 2 zeros, and then 5 squared, this is plus 5, this is minus 5. So 5 squared is 25, and this here is 2025, right? Way too high. So answer A. Find the remainder when this is divided by 7. This is a simple division, so we just simply say, okay, well, 2, 4, 3 divided by 7. So we take 7 divided by 2, that's remainder 2, put it over here. 7 divided by 24 is 3, remainder 3, put it over here. 33 divided by 7 is going to be 4, which is 28, put a decimal point, put a 0, and then the remainder is going to be 5 here. All right, 5 here as the remainder. So we can see that 34 and 5 over 7 is equal to 243 over 7. All right, so that remainder there is 5. Okay, let's do some structured questions now. And what we'll do in this section is I will use the calculator a lot. So this way you can get to see how to use the calculator to perform most of these things or get these answers the way that you desire. The first one that we're going to do is we're going to take all of these questions and solve it with your calculator. All right, so let's start with the first one. So the first question says that we have to add some fractions together. And if you remember correctly, the fraction was 5 over 6 plus 2 over 3 minus 12 over 35 times 7 over 9. So let me add that in here right now to show you. So we say 5 over 6, that A/B button there means fractional values, right? So 5 over 6, put the cursor to the end, put the operator, and we follow and repeat for the exact same things. So 2 over 3, put the cursor at the end, put the operator in between, 12 over 35, put the operator in between at the end after I move the cursor, so that's times, and then 7 over 9. And when I press the equal sign, I get my answer of 1 and 7 over 30. All right, I can change that answer's form by just simply pressing this. All right, I can change the answer's form. And this is the form that I will accept, 1 and 7 over 30, because they ask for the exact value. So this is equal to 1 and 7 over 30. Next, we're going to do this question here. Now, I can set my calculator in such a way that I can get my values to 3 decimal places. No matter what it is, I'll get it to 3 decimal places. I'm going to be using cos of an angle, and notice that this angle is in degrees. I'll show you what that means on your calculator just now. So let's take the calculator and try and see if we can work this out. All right, back to the calculator now. This is what we have here. First, I'm going to set it to give my answers in 3 decimal places. So I'm going to press setup. I'm going to go with FSE, so I'm going to say 1. Then I'm going to say FIX, which is 0. And then I'm going to choose a value between 0 and 9 for the tab. And that value I'm going to choose is 3 because I want 3 decimal places. Now notice the answer here is still in fraction form. If I press change, it's still going to give me the improper fraction form. But when I press change one more time, my answer now is to 3 decimal places. And that's going to happen for every answer right now. So I can check that out, cancel. I say 5 times 1.2368, and I will get a long answer, but it will only give me 3 decimal places for my answer. All right. Now, if the answer can be given in the form of a fraction, that's what this calculator does. It gives you it in the form of a fraction. I have yet to figure out how to put it default as decimal. Anyway, so this is going to always give me my answer as a fraction. All right. If it's not possible to give it as a fraction, it'll give it as a decimal. Anyway, that's off topic. Let's go back to the question that we have at hand. Now, remember, we have to calculate the value of the square root of 1 minus the squared value of cos 37, all right? 37 in degrees. Now, this up here that you're seeing, this DEG that you're seeing up here, that stands for degrees. Now, you can have different modes, for example, RAD, which is the other one that you will encounter during this exams. So you press second function and this, and it goes to RAD. Notice that it says RAD, it's going to RAD. We're going to go back to degrees because the value that we're working with is in degrees. It's 37 degrees. So let me type in this on the calculator so you can see exactly how you would go about doing that calculation. So square root of everything, and I'm going to put a brackets just to ensure that it stays inside of the brackets, because some calculators, they don't have the square root going over it like what would happen in this one. And I'll show you as I keep typing it. So 1 minus, so notice how the square root is extending. Not many sharp calculators do that. All right, so I tend to put a bracket just to make sure that I know that this is everything that I'm square rooting. Anyway, so I'm going to open up a next bracket after the minus sign. I'm going to put the COS of 37. Now, because my calculator is set to DEG, it's going to assume this value of 37 is in degrees. Then I'm going to close the bracket. I'm going to square that with the x to the square button, and then I'm closing off that bracket. And notice how the square root sign extended to show me everything that I'm square rooting. Some calculators, as I said, don't have that. Now all I have to do is press my equal sign, and I got my answer, 0.602. So the answer to 3 decimal places, 0.602. All right, write this in standard form. Now another way you can say this is in scientific notation. Right, standard form and scientific notation are the same things. So I have 0.00527. I can use my calculator to get my answers in standard form as well. All right, so back on my calculator now, let's change this to scientific notation. And I'm going to leave the decimal places as 3. All right, so I'm going to do a setup again, and I'm going to go back into FSE1, and then I'm going to look at SCI, and I'm going to put 1. And now I'm going to set the number of decimal places. Again, I'm going to keep it as 3. And I'm getting my answer now, 6.02. So it gives me my answer, not 3 decimal places, but 3 significant figures. Now let's go and look at the value that we have. We have 0.00527. Let me write that out. 0.00527 equal sign. I get it as a fraction, I press it as this, and I get it as my scientific notation. 5.27 by 10 to the minus 3 on the calculator. Now, I can simply say, okay, well, 0.00527, and I can say 1, 2, 3 decimal places. I'm moving it to the right, so it's 5.27 by 10 to the minus 3. All right, so a calculator can do the scientific form for you as well. Next, using a calculator, otherwise calculate the exact value of this, I will use my calculator. Let's go to the calculator. So back on the calculator again, I take 8, I use fraction, and I say 0.4, and then this y to the x button gives me any power that I desire. So 3 is what I'm going to choose, and I'm going to get 1.25 by 10 to the 2. Right, so I don't want my answer like this. I want my answer as a normal answer, so I'm going to go back to setup. I'm going to go back to FSC, since that's what I used to change it. 1, and then I'm going to set it back to normal, so which is normal 1 for me most of the time, and I get my answer as 125. Let's see what else we have to do. Using a calculator, otherwise find the exact value of this. All right, I can use my calculator again to give me the exact value of this. It's not going to be difficult or challenging. I have done all of these here for you so far. Back to the right view again. Let me show you how it's done on this right view. So I will type in square root of 26.8, and then I'm going to come with the cursor out of the square root sign, and then I'm going to say minus 2.5, and I'm going to use this y to the x button, and I'm going to put 3 over 2. So 3, backspace, 3 over 2, and now it's written as a fraction. Notice that's the completed question right there for me. All right, and I press equal sign. I will get 1.224024567, and I can't get that in the form of a fraction, because it's not possible for me to get a nice fraction in the corner here. So what I'm going to have to do now is I'm going to have to write this, and they asked me for 2 decimal places, so I'm going to go back to setup. I'm going to FSE1. I'm going to fix, which is 0, and I'm going to choose 2 decimal places here, and then I will get 1.22. So back to this. Next, we're doing a ratio question. And I will use my calculator, but I don't need to use my calculator much. So let's say ratio of teachers to males to female students, teachers to males to female students in a school is this. So this is teachers to males, male students, I should say, males to, males to, fees to, right? And if the total number of students in the school is 630, total students, they want you to determine the number of teachers. Okay, male students and female students makes up the total amount of students in the school. So 17 plus 18 is how much? So 7 and 8 is 15, and then 1 and 1 is 2, and then I get 35. So I say a ratio of 35 is what will represent 630. So 35 shares represent 630 students. One share, and I should really say this as persons, person, right? So one share would represent 630 divided by 35 persons. So 630 divided by 35 will give me 18. So that means I have 18 persons for each share. I have 3 shares representing teachers. So that means 18 times 3, which is, but yeah, let me do it like this. I prefer this. So 1 by 3 is 3 with a 0 additional, and then 8 3s are 24. So that's 54. So in other words, this school has 54 teachers. All right. So the answer looks a little bit scrappy. I did not give a formal answer. I'm just giving you the working and the methodology. I require you to do more of a formal kind of working. Right, and that's it. That's the first exercise sheet for CSEC Math, and we're going to go on to the next section of the syllabus, and we'll do that tomorrow. Bye. Enjoy the rest of the evening.